2-1B notes. We start out with the definition of the unit of measurement we use to measure an angle. Anybody know what that is? Yeah? It's a degree. A degree is the unit of measurement we will use to measure an angle. A ray revolved completely around its endpoints makes an angle measuring how many degrees is all the way around a circle? Yeah.
360.
Yeah, it'd be 360 degrees. Now we can come up with smaller units than a degree. The unit smaller than a degree is minutes, right? There's 60 minutes in a degree, and then smaller than that would be seconds. 60 seconds in a minute. Okay, but it's not time. It's the angle measure that we're talking about when we say minutes and seconds. So this would read 32 degrees. 15 minutes, 40 seconds. All right. Any questions there? Remember, 60 minutes equals 1 degree, and 60 seconds equals 1 minute. Do I have it? Okay. Protractor. A protractor is used to measure angles. Your protractors are not in yet, so I'm just going to have to show you on the overhead how to measure an angle with the protractor. You probably did you do this in middle school? Okay, so you probably have an idea how to do this, but I want to make sure you know how. Alright, so with the protractor, there's usually like a hole or lines, perpendicular lines intersecting at where you put the vertex. Right, so I'm going to put this hole right over the vertex there, or the crosshairs there, right over the vertex, and then the straight line, you line that up with the line of your angle. You can see that line there. I line that up right on the line. So it looks like that, okay? And then to measure the angle, the tricky part is using the correct scale. Okay, so we're doing ABC. This is angle ABC. Okay? So, I have to determine, do I use the inner scale or the outer scale? Well, if your starting point is here, that's 0. So that means I'm going to use the inner scale, and ABC would measure 10, 20, 34 degrees. Okay? ABC is 34 degrees. Now, EVD. EVD is on this side, right? So E is my 0. So now I find the scale that starts at 0. It's the outer scale. All right? So it's going to be an obtuse angle. So its measure looks like it's going to be about 111 degrees if I extended that line. Okay, I don't quite have it lined up right. Let's get this lined up better. That's better. So you can see, yeah. BD is 100. Well, it's still not lined up. I'd say it's 110 degrees. I usually give a little margin of error. If I ask you to measure something like on a test or quiz, I'll say plus or minus 1 or 2 degrees because like the difficulty I'm having with getting it lined up perfectly. I know that's hard to do. So, anyways, anybody have any questions about measuring an angle with a protractor? Okay, so if you, on the homework problems that you're assigned that ask you to measure the angles with the protractor, unless you have one, you can just go back to those. Once you get the tools, go back and practice those. Remember to go back and practice those on your own. All right. So we measured the angles. All right. The type of angle and its measure. An acute angle is between 0 degrees and 90 degrees. Acute angle between 0 degrees and 90 degrees. A right angle is 90 degrees. An obtuse angle is between 90 degrees and 180 degrees. A straight angle is 180 degrees. And a reflex angle, we won't be doing anything with the reflex angles. There may be one homework problem the whole year that asks about a reflex angle. It's the long way around, okay? It's if you go the long way around when you measure the angle, it's between 180 and 360 degrees. Any questions on naming angles? Okay, let's look at some examples. We've got an acute angle. We've got a right angle. Here we have an obtuse angle. Straight angle. And there we have if I go around this way, that would be a reflex angle. Okay, any questions? No questions. Okay, very good. Definition. Perpendicular lines are two lines that form a right angle. If L and M are perpendicular, we write L perpendicular to M, and that would look like a picture of that is, we can call this line L, this line M. Okay, you put a little box where we have perpendicular lines. All right, any questions there? Two angles that have the same measure are said to be congruent. So here we have angle ABC, and here we have angle DEF. ABC is congruent to DEF. We mark that with an arc with a tick mark in the angle, or 2 tick marks, however many, just as long as they're the same number of tick marks. That's how you would show they're congruent. The textbook, I think, uses arcs. It'll have, rather than the tick mark, it'll have maybe 2 arcs in each one. That shows that those two are congruent, or the same number of arcs shows they're congruent. Could be 1 arc and 1 arc, just as long as it has the same number of arcs. Now we write the symbol for congruent. Angle ABC is congruent to angle DEF by the congruent symbol. All right, any questions there? Okay. What do we call angles whose sum is 90? What do we call those angles? Anybody know?
Complementary.
Yeah, they're complementary. Complementary sum is 90. Now these angles, complementary angles, don't have to be touching. Now I could have a 30-degree angle over here and a 60 over here. They'd still be complementary. They don't have to be together. They can be, but they don't have to be together to make complementary. So 2 angles that sum is 90 are complementary. And 2 angles whose sum is 180 are what? Yes?
Supplementary.
Supplementary. Very good. Supplementary. Now I always had a hard time remembering which was which. Which is complementary, which is supplementary. So a little thing you can use to help you remember that is a supper table is flat, right? It's 180 degrees. So supper table, flat, 180 degrees. That's a supplementary angle. It's 180. They add to 180. Angles who share a common vertex and a common side are adjacent. Okay, they're adjacent. Angles who share a common vertex and a common side. Adjacent. So adjacent means next to. They're right next to each other. Okay, so let's in this drawing we could say that give me a name 2 adjacent angles. Give me 2 adjacent angles here. Yeah.
Angle DCB and angle BDC.
DCB and what?
BDC.
I can't hear you.
Angle BDC
Yeah.
and DCB.
Okay, BDC would be this angle. BDC would be this angle. And did you say CBD? That would be this angle. Those angles are not adjacent. They are.
I said DCB. Sorry.
DCB. Oh, okay. Well, anyways, those the adjacent angles. I don't know if I'm hearing you right or not. I'll just tell you what they are. Adjacent angles would be angle ABC, this angle, and this angle. They're adjacent. They're next to each other. They share a ray. Remember the definition of adjacent. They share a common endpoint and a ray, a common side. Here's the common side they share. So angle ABC and angle CBD are adjacent. They're adjacent. They're touching. Okay. Now we've got complementary angles. Angle CBD and BDC. Are complementary. 34 plus 56 is 90. Those two are complementary. Everybody got it? Okay. Then we've got angle ABC and angle. What angles would be supplementary? Yes.
Angle CBD.
Yeah.
Angle ABC.
Yeah, the same ones we named for adjacent. Angle ABC and angle CBD are supplementary. All right, any questions on adjacent, complementary, or supplementary? All right. Now, this next exercise here, all right, there's going to be a question like this on the quiz or the test. Okay, so make sure you go back through this. Star this in your notes. You go back through and make sure you can do this. Students have trouble with this. I'm not sure why. It's you just have to understand what complementary, supplementary, and adjacent are. All right. If you don't understand it, then you won't be able to answer these questions. Okay. So let's first of all we'll find the missing angle measures with the information they give us. We've got CG perpendicular to GE. And we've got AGB is 77 degrees, CGD is 54, and FGC, okay, we have to figure out what, no, it tells us that FGC, this angle, is 157. We use this information to do the following. We need to find angle DGE. Okay? Angle DGE, what would its measure be? DGE. Yes?
36 degrees.
Yes, it'd be 36. Because, how'd you get that?
You know that CGE is a 90-degree angle, so you take 90 minus 44.
Right. She knew that this is a right angle and CGD is a part of it, so the rest of it would be 36. So angle DGE is 36 degrees. Okay? So that's 90 minus 54. Okay, BGC. What would BGC be and why? Go ahead.
80.
What?
Would it be 80 degrees?
It's not 80. Yes?
49 degrees.
How'd you get that?
You know that AGD is 180, and then you know that AGB is 77, and then CGD is 54, so you just subtract both of those from 180.
Correct. 180 minus 77 minus 54. 49. Right? AGF. Okay, so we have this as 49. How am I going to what's AGF?
And how would I find that? Yes, go ahead.
31, because up there it says that FGC is 157, and since you already have AGB and and BGC, you can subtract those.
Right, 157 minus 77 minus 49. Correct, 31 degrees. FGE, how would I find FGE? Yeah. What's that? Yeah, 113. How'd you get that?
Well, we already know that AGF is 31 and EGD is, I got EGE is 36 and AGF is 31, and then the rest is, I subtract them from 180.
Yeah, we subtract those from 180, so we've got 180 minus 36 minus 31. All right. Very good. Any questions on finding the angle measures? Okay. Now, name one pair of complementary angles. So when it asks for one pair of complementary angles, that means you're going to name two angles. Those together are the pair. It doesn't mean you name two pairs, two different sets of complementary angles. It says one pair means two angles, right? That's all you're going to do. On the going back to this question on the test, people put more than what they need, and if it's wrong, I count it wrong. Even if you have one right pair, if you name a second one and it's wrong, I'll count it wrong. So don't give more than what it wants. It wants two angles together that are complementary when it says name one pair. So give me a pair of complementary angles. Go ahead, y'all.
CGD and EGD.
Yeah. Angle, it's this angle and this angle, right? They're marked with the 90 degrees. So that would be angle CGD and angle DGE. Very good. Complementary angles. Supplementary angles. Name four pairs of supplementary angles. Okay, so give me one pair. Now, with this, I'll give you one. Okay, supplementary means they add a 180. So we could take this angle and this angle and say they are supplementary. Okay? So don't let this line right here throw you off. Students see that extra line in there and they think, oh no, that's more than two angles. They can't be supplementary. Just ignore it. As long as the rays you pick make 180, it doesn't matter if there's other angles inside of them. All right? So like another thing I see when people answer this question is they'll put three angles. That's not a pair, right? Three angles aren't supplementary. Two angles are supplementary. So we're taking the angle in this one I've highlighted. We've got angle AGC and angle CGD. Those are supplementary. Right? That's my pair of supplementary angles. Okay, somebody give me another pair of supplementary angles. Yes.
Angle AGB and angle FGE.
AGB and what?
Angle FGE.
FGE? Do those add to 180? Right? Well, 113 FGE is 113, and AGB is 77. Yeah, they do add to 180. I haven't seen that one before, named before, but you're right, because this is 113. So we would have angle AGB and angle FGE. Very good. Okay, that's a pair of supplementary angles. Okay, name another pair of supplementary angles.
AGB and BGD.
AGB and BGD?
Yeah.
Yes, these two are supplementary. So we have angle AGB and angle BGD. Alright? Those are supplementary angles. Alright, that's enough. I'm not going to do another example. Everybody get the idea? Alright. Let's do pairs of adjacent angles. Okay? All the angles we just named would be adjacent. They shared a common ray. Let's name a couple more that aren't necessarily complementary or supplementary, just two adjacent angles. Give me an example of an adjacent angle. Yes, go ahead. AGF, FGE, very good. Angle AGF and angle FGE, very good. Give me another pair of adjacent angles. I'm going to start picking on people that aren't answering. Susan.
Angle AGB and angle BGC.
AGB, BGC. Angle AGB and angle BGC. Very good. Questions there? Everybody got the idea? Okay. Then the next thing it asks is for you to name two acute angles and two obtuse angles. So let's do acute and obtuse. It's not asked, these aren't in pairs, they're just single angles. Let's just do one. Name an acute angle. Yes, go ahead.
Angle CGD.
CGB, yes, it's, what was CGB? CGB was 49 degrees, right. So angle CGB is acute. Okay, somebody name an obtuse angle. Yeah, go ahead.
Angle FGC.
FGC, yes, that's definitely acute, more than 180. Angle FGC. Okay, everybody got the idea? Okay. All right, so now we're going to do clock problems. Okay, so clock problems. Find the measure of the angle of the hands of a clock at the following time, 3:30. Okay, so when we do clock problems, let's think about a clock. A clock is divided into 12 parts, right? It's number 1 through 12. Those are sections of 5 minutes. How many degrees is 5 minutes on a clock? How many degrees would that be?
30.
How'd you get that?
360 divided by 12.
Yeah, he divided 360 by 12. So that's the key. Remember that 5 minutes equals 30 degrees. All right. Now, from that, we could also get what would 1 minute equal? How many degrees would 1 minute be? Yeah? How'd you get it down? Yeah?
Sorry.
Yeah, we divide 30 by 5. 1 degree is 6. 1 minute is 6 degrees. You don't have to, you aren't going to use that in the problems I give you. There might be a homework problem where to ask something that involves that, but we're going to be working with either the numbers are either going to end in 5 or 0. So we won't have to worry about the single degree. Let's look at the clock. We draw a clock, right? You can divide it into 12 parts. Right? The clock is divided into 12 parts. The first thing you're going to do when you do a clock problem is you take, so the number of minutes, 330, our minutes is 30. You take the number of minutes, 30, and you divide it by 60. That gives you 1/2. Right? That gives you 1/2. Now, I take that back. The first thing you should do is draw the hands on the clock. So the hands on the clock, what is the minute hand going to be on at 3:30? What number? $3:30. What number on the clock is the minute hand going to be? 6, right? It's going to be on the 6. Where's the hour hand going to be? Don't say it's going to be on the 3. It's not on the 3. Where's it going to be? Yeah. Yeah, it's going to be between 3 and 4. Halfway between 3 and 4. Right? Now that's obvious that that's halfway. If we had some other minutes like 25 minutes, then that's why we do this deal with the minutes divided by 60. Right? You take 30 divided by 60, that's 1/2. Right? So that's going to be tell you what fraction that this is. The hour hand is past the 3. It's past half of a 5-minute section. That means what's left is a half as well, right? So then you write your equation. How many whole sections of 5 minutes do we have between these two hands? Whole sections of 5 minutes. How many?
3.
No, we don't have 3. Go ahead.
2.
You have 2. So we're going to take 2 times 30 degrees. That accounts for this. All right? 2 times 30 plus. Then we have to do the fraction. 1/2 of 30. So that's going to give me 60 plus 15, 75 degrees. All right, any questions there? No questions. Okay, let's do another one. Instead of 9:25, let's do 9:10. I want to do 9:10 because it deals with a fraction that I want to show you how that works. So you draw your clock and the minutes and hours that are necessary. So what's the minute hand going to be on? What?
2.
Yeah, it's going to be on 2. Minute hand's on 2. Hour hand is after 9. Before and it's between 9 and 10, right? We have to figure out how many what the fraction it is past the 9. So I take the minutes, 10 divided by 60, and I get 1/6, right? So it's 1/6 past the 9, right? That's 1/6. That is 1/6. Now, we've got whole sections of 5 minutes. How many whole sections of you go the short way around? Don't go around this way. So we're going to go around, even though we're going backwards on the clock, we're going to go around this way. Because you go the short, we don't want a reflex angle, we want the shorter angle. So how many whole sections of 5 minutes do I have? Yeah, we've got 4. So it's 4 times 30 plus, okay, what fraction am I going to use now for the minute hand? Yeah.
5/6.
Yeah, why'd you use 5/6 instead of 1/6?
Because that's how much is on an angle.
Yeah, that's we're worried. We're not concerned with this amount. We want this right here, right? So we subtract 1/6 from 1, and what I'm left with is 5/6, right? So it's plus 5/6 times 30. So that's going to be 120 plus 150 divided by 6. So that's going to be 120 plus 25, which is equal to 145. All right. Any questions on clock problems? No questions on clock problems. Okay, very good. Any other questions about the notes? Okay, so